So good morning, everybody. Welcome to our ASC webinar. My name is Mario Bacchus and I'm the host and moderator for today. Today, we would like to discuss a very hot topic, sustainability and energy savings in process industries. Our target is to explore a pragmatic approach for quick implementation and transition. Together with Maxime, Mathieu, and Thomas, we would like to share best practice and use cases with you. So please use the chat to post your questions. I will collect all questions for our frequent asked questions at the very end. This webinar will be recorded and you will receive a link to share this with your colleagues. So just get started with a personal introduction. Maxime, please take over.
Hi, Maxime Cageli. I'm a French engineer. I'm based in Chambéry and I'm the co-founder of Rongi Solution, which is providing services in the decarbonization and climate risks for mostly industries and mostly in the process industries such as chemical, energy, and metal. I have a background in the chemical industry globally.
You?
I'm Mathieu Cura. I'm one of the co-founders of Optimistic. We founded the company a bit more than 8 years ago. And previously, I worked 10 years in the process manufacturing industries in large biotech company, and then moved in the energy sectors during 4 years before creating Optimistic.
Okay, Thomas.
Hey, I'm with ASC. I'm a senior consultant at ASC. So my background is really process automation, and I'm doing market research on quantitative and qualitative topics regarding process automation and the, let's say, new technology trends and transformations.
Okay, so let us get started with my observation regarding sustainability. Nowadays, there is no event and no fair without this hot topic. But to be honest, it is very often more about a holistic approach than a pragmatic approach. So today we want to go pragmatic. So take it to the next level.
Okay, Mario, let me take over here. Yeah. So whenever we, ASC, really discover new trends in the industry, we observe different behaviors on the customer side. There are more or less two different methods how to implement these kind of trends into their business life. And at this time, we are going to discuss really sustainability. So to reduce the carbon footprint, nobody is in doubt that this is definitely an important initiative, and everybody has to consider this. But even here, we see in practice two possible approaches for the implementation. But let me first explain a little bit what sustainability in industry really means. So sustainability in business refers to the company strategy to really reduce negative environmental and social impacts caused by its operations. So, and that involves a lot of measuring and really balancing the economics, the social, and the environmental responsibility of a business. Sometimes you have to change things. So it's a big topic. It's really a big topic. And even here, we see at this moment in time two different ways how to react, how to implement sustainability. And there's, of course, the superficial approach. This superficial approach is nothing bad, but it's limited. It is really, the company is not changing their business model on its own. It is maybe done to be compliant and to achieve a couple of cost-saving factors, but it does not reflect really the full commitment to sustainability. And this is sometimes more or less a greenwashing, which is when a company misleads about its environmental performance. So again, the superficial approach, and the other thing, the opposite is really this transformer approach. And that is really, that happens if a company really embeds sustainability deep into the core business strategy. and alliances with the internal vision and values. So this may require rethinking of the company's production methods, services, and processes. And sometimes you need to involve stakeholders as well, that they really understand what happened in the company. And the transformal approach quite often goes hand in hand with innovations and collaboration. And collaboration means you get experts from the outside to get this job really done. So that means this transformal approach is more likely a long-term or creates a long-term success story and delivers competitive advantages. And this is, let's say, the beneficial aspect regards this superficial approach, but that needs to be really discussed here and today. And with this intro, I would like to pass over to Maxime. He is really an expert on this ESG and being more sustainable in industry. And Maxime, stage is fully yours. I'm really motivated to listen to your explanation.
I will try to be insightful then. So just when you think about why are companies transforming, they're transformed for two reasons: because they want to and because they have to. And for having been in the chemical industry for many years, where I take the example of safety transformation, for instance, why did we want to transform for safety? Part of it because it was an important value that our coworkers will not get hurt working in the industry. It's very similar here for the environmental impacts. We find people, and that's the one at the top left, who think ESG as a commitment to a societal commitment, and they want to do good, and they are convinced that they have to lower the environmental impact on the planet. I would say that we actually see less people coming from that angle than coming from all the others, where they have to transform. The biggest one that I can think about, the one that is driving more people in the industry to transform, are the stakeholders' pressure. And there are lots of different kinds. Investors, why do people have to go transparent on carbon footprint today? Because you have some loans and some insurance rates that are linked to the fact that you have done your climate assessment. Customers want it. We are working with value chains where it's really clear that when P&G or when Henkel say we want to commit to the Paris Agreement and reduce our greenhouse gas, we need to work with our suppliers and we need to understand their carbon footprint. So this transparency, that's a bit where it's coming from. To attract more people in the industry, you also need to show today something which is attractive, and it's part of the attraction of this. And there are lots of regulations, and I'll come back to that in a minute. Now, there are lots of co-benefits in doing that and tackling the carbon and doing stuff with it. The first one is on cost and competitiveness. Typically, GHG is energy. If you reduce your greenhouse gas, you will more than likely use the energy better. So there's a lot that the company can gain when you see what the gas prices have been doing in the last 2 years, for instance. And spoiler alert, it's likely that oil and gas will continue to increase, and it's harder and harder to find. On the resilience side, so it's also a way to pivot, and I really like the fact that you introduced the fact that it's an opportunity for transformation, embracing this change and saying, well, actually, I'm very dependent on countries, on sources of supply for my raw materials and energy that are complicated. So thinking all this in terms of resilience is also very, very instrumental. And I'll go back to the regulators, the formal and informal regulators. And if you go to the next slide, Mathieu, there is a handful of things that push you to be transparent on your carbon footprint. There are lots of referentials, some are mandatory, some are voluntary, that are pushing companies to reveal and to publish their carbon emissions. I will start with the voluntary one that I think lots of people have heard about. People in the chemical industry, for instance, Together for Sustainability is basically a framework that lets you define how you want to report your carbon footprint. It's becoming very prevalent in the chemical industry. But for companies that are on the stock market in the US or work with companies that are on the stock market in the US, TCFD is being put in place by the CEC to capture all this. And there are multidimensional activities also in ESG, but all of them have an inclusion for a revealing, basically, of the carbon footprint and some transparency in the food chain. And companies of all sizes are involved because smaller companies are sometimes between big companies and big suppliers and big customers, and they have to comply with the systems of larger companies. The last one, which is in everybody's mind right now, is CSRD. CSRD is the double accounting of impact of company on the climate and impact of climate on the companies. And for impact on climate, having a GHG assessment is absolutely critical. So it's clear that it's coming from everywhere and companies have to comply.
Okay, Maxime, if I understand you right, we need a piece of software coordinate all these efforts. And from my point of view, enterprise software could be one solution because there exist software models who really steer your business towards better decisions based on ESG measurement. So these software solutions these software solutions enable really organizations to define and manage ESG standards, framework, and of course the required disclosure requirements. So should we use, what's your recommendation? Should we use these kind of enterprise software, or are there, let's say, specific bespoke design software tools outside the enterprise software who are supporting these processes? Because sooner or later, we have to motivate all people in the company really to be compliant to these ESG initiatives if we want to achieve this transformer approach. So what's your view? What's your recommendation?
So it's a great question. I think that's the one that all industries are struggling with. Do you want to comply first and then transform and use this as an opportunity? It's true that ERP in general has the simplicity of covering everything that is in the GHG inventory. When you want to understand the carbon footprint of a company, an activity, a service, or a raw material transformation, or a distribution, you are working in cradle to grave approach. From the time you supply your raw materials to the time that you actually go down the value chain and eventually sell to customers that will dispose of it. And typically, all companies have ERPs that capture this, right? You need to pay all your invoices upstream, and you need to know all your customers and supply, and in between, you are paying for your energy bills. So you would think, well, starting with ERP is great because I would have all the basic building blocks. And calculating GHG is easy. So on the next slide, you can see it's not rocket engineering. It's typically a multiplication of an activity data and something called an emission factor to calculate the emissions. So an activity data can be the kilowatt hours of gas that you've bought, of the tons of steel that you purchased, and the emission factor is basically this dimension that relates the emissions that are linked to the purchase of the service or the material. So if you buy a car, a standard mid-size car in Europe, the total footprint is 8,000. It's about 8 tons of CO2 that is emitted for the make of the car. So if you know the number of cars that you bought and you can find it in the ERP and you multiply by this standard, you will get a number. Now, devil is in the details, right? Because if you are living at the spend that you typically find easily in the ERP, and I've been in many SAP implementation, you typically stay at a pretty high level. You sometimes have some breakdowns and recipes, but you come at a high level. And at a high level, it is much harder to pilot a transformation. And I will show you a little bit, basically comparing the ERP versus operational level in the next slide. If you take ERP-based accounting, you take what is called monetary ratios. So, and it exists, right? I have databases that tell you if you spend 100K euros in maintenance services, this is how much CO2 you will emit. And this is done at a very high level, industry level, where they take the revenue of all the companies that are making maintenance in industrial setup and divide it by the supposed emissions. And they come with a number, but it's very high level. This is database driven in general, and not all data that you find are of very good quality. On the operational level, you want to be linked to the physical flows, so the transportation, and actually back to my example of industrial maintenance, you will understand the number of valves that you purchased, the number of welding operations that you've done, the consumption of argon in the welding. You will go in much more details, and I think we've all lived through the implementation, the difference between having an income statement in an ERP And the cost to serve model is exactly the same thing here. You move from a kind of what I would call collective punishment to a much more individual, tailor-made, bespoke number. So the characteristics of the ERP is like it's pretty coarse, undiscriminating, so it's hard to know how to reduce, right? Except by spending less. And sometimes spending better is a good way to reduce. So you need to think about that. You might want to spend a little bit more to have something which is less emittive. And it's not something that the ERP can tell you. I think that from an industry standpoint also, it's market-based. So basically, I will never be better than the industry next door if I stay at ERP level, because they will use the same database. And in the end, we are not competing, right? We are just giving a number. So it's super easy on the ERP side, and you find very cheap software that can help you do that. But it will not be. You might be in compliance. It's a lot of green paint, but it's probably what is transforming. So I would say that if you manage to basically go back to the bombs, to the formulation of materials, to the time-based consumption of energy depending on the time of the day, you will be able to move the decision-making from a very high-level course, which is spend less, do less, shut down the business, to do more of what counts. It's exactly the same transition that happened between managing the business at a national level, income statement level, on an annual basis, down to optimizing your products and customers, like you can do today with variable margin calculations and stuff like that. And I've been in such implementations of systems to evaluate variable margins at a low level, and you get so many insights, because then you can do better. You don't need to do less, you can do better, and it's critical. Now the little problem is like, it's complex.
Yeah, thank you for these really interesting insights. I think you clarified the topic perfectly. So even I, as an amateur, understood and followed your idea fully. So I'm really looking forward to see now, let's say, practical use cases, how to do and yeah, what are the opportunities?
Okay, thanks, Thomas and Maxime. I think really what said Maxime, which is really interesting, is that devil is in the details. In order to be able to transform, we need detailed information about what happens in the manufacturing process. So one of the keys to be data-driven in its plant operation in general and in its industrial operations. And I will not go again into the details, but really, one of the key aspects is traceability. How can I trace what I have done in a sufficiently granular way that allows to understand clearly what is happening in the plant? This is important, particularly to go further than just reporting. I will say traceability is here to give a detailed and reliable reporting, either financial or extra financial, as it's becoming more and more compulsory. But on top of that, traceability allows you to have a very fine vision of what is happening in the plant and will help them to work on the different level of industrial performances. And this level of industrial performances, they are closely linked to sustainable development. Typically, when we talk about raw material efficiency, when we talk about energy efficiency, it's really here where we can impact to reduce at the end the emissions, the waste volumes, and be more efficient at the end, because I would say one of the key things is to be efficient. Just to give more, I would say, concrete, pragmatic approach on one specific aspect. If we talk about energy and emission, the idea is we will have to work with a wide range of type of data in order to build the proper information with the proper traceability. So first, in all your industries, you have data coming from the process control system. You have also data coming from all your different metering devices, electricity, gas, emissions, environment. But typically metering data, it's somewhere where often there is some investment to be made, because you don't necessarily have all the meters to have the proper detailed view of what's happening in the plant. So again, it's a, I would say, systemic approach which is needed, not just only a solutions approach. Then you need to have a detailed information about the traceability and the genealogy of your production from the raw material to the final product. And also to get data from the supply chain. And one of the key aspects, I think, in the coming 10 years will be, companies share in a very smooth way data from their final product to their customers. So we can propagate the information related to sustainability all along the value chain. Typically, or we can share between a chemical company and a consumer good company, or we can share the carbon footprint of each batch of product that is delivered. This is something that will become, I will say, I think, a standard in the coming 10 years. And we need also market data. Maxime talked about the oil gas price, but you will also have market data for CO2 emissions and other, I will say, products that are related to energy. At the end, when we talk also a lot about water consumption today, because it's a resource that is becoming scarce and it's having impact on our industrial operations. So really, market data and open data will be another aspect. And if we take all this data, we structure them in a good way, and we combine them together properly, and this is where we work at Optimistic with our OI analytics solution, then we can work on several aspects of the energy and emission efficiency. The first thing is to understand the footprint, energy and emission footprint. And this at the proper granularity, that means what is my consumption for this batch of production? What is my unit consumption or emission per type of product? And this is really interesting and important in order to be able to make strategical choice. Maybe sometimes to say, okay, this product line is nonsense in terms of emissions, and we need to discard this product line. But it also helps to improve, because if you have just a global vision of your emissions, and you have several products in your portfolio, how can you improve? You need to go down to the specific consumption per product to be able to improve. Then you can also implement energy arbitration. This is something that is becoming more and more real, particularly in chemical industry and in metallurgy industry, where you can have double energy systems, where you can switch between gas and electricity. And at the same time as you reduce your carbon emission by using electricity, decarbonated electricity, you can also at the same time keep some agility to cope with very high electricity spot price and move back to gas when it's important to keep a good competitiveness. Because at the end, if you are perfect on emissions, but your company is going bankrupt because you are not anymore competitive, you really need to have all this agility. So energy arbitration is one of the aspects. One key point, and this is, I would say, something really key, is optimization. How to optimize each unit step of the production process, but also to have a global overall optimization, because you can have, I would say, both approach depending on the interaction between the different steps of your process. And as we mentioned, all the compliance reporting. And also another aspect, but which is more related to optimizing your purchasing costs, which is to have consumption forecast in order to anticipate and optimize the purchasing cost, mainly of energies. So this is some, I would say, trends we see on the market and use case that are leveraged by our customers. How we do that, and here it's where our solution brings new approaches. What we do at Optimistic is to try to simplify the use of data, so a maximum number of people in the plant use data on a daily basis to tackle all the different challenges they have. So here is just a screenshot of a dashboard where you see how we combine traceability data you have on the right side together with sensor data in order to be able to have this specific KPI. So here, in that case, we have a process where we produce some dough to make cakes. So you have the traceability of this production on the right side. And we measure some energy power consumption on equipment. And this is what you have on the sensor data here. And by combining all of that, we are able to compute in a very simple manner the proper KPI. So in that case, is the energy consumption for this specific batch for the mixing and energy consumption for other steps. And then we are able to have an overall knowledge in terms of energy consumption for one batch. So we created data information at a very fine granularity, and this will be exploited both for reporting and for improving. So the idea is all this is to be able to handle the process complexity, because okay, it seems simple to understand energy consumption in a plant. In fact, it's not. Just taking one example, let's say you have we have in that case a blender. So this blender sometimes is waiting for production, and it can consume some energy during this phase where there is no production. So the ability to be able to track productive and non-productive periods allows to allocate the productive periods to the batch that is concerned by this production period. And the unproductive period, here we can accumulate the energy that is in a way lost just by waiting for production, and then can be allocated in average to all the batches. And so this is for reporting, but it's a good example of where data can help also to improve, because as now you know how much you lose in terms of energy due to waiting times, you can find ways to change the organization of your production, or maybe optimize your equipment to reduce this consumption when it's in waiting time, etc., etc. So really, the idea is we go in a very fine granularity in order to be able to handle the complexity of the process, and because this complexity is important to make the good choice and to optimize afterwards. Then there is also, as we talk about data, about fine granularity, that means you will have a lot of information to handle. And then this is where analytics can come in. And by analyzing the process using either statistics tools or tools using machine learning or AI, you are able to understand better the process. What are the components of the variability of the specific consumption or specific emission? And then be able to understand which parameters to control and what are the best operation points. So after that, you can put all this under control. And at the end of the day, you have very good reporting, very fine reportings where you can see, and you can also keep track of the improvement you are making and see whether, I will say, the theoretical improvements you should have due to the action you are putting in place, they are really giving the result you expect.
Mathieu, if I see your slide here, analyze and optimize processes, something comes into my mind. I think in the beginning we said the transformer approach is more sustainable than the superficial approach, and that means we have to motivate all the employees to using this opportunity, taking fact-based decisions. So from your point of view, from your experience, what is really necessary to increase the level of acceptance using these kind of digital screens, digital information, and maybe calculated results to optimize the production processes?
I think it's really a good question, and it's not just about data for this sustainability aspects we are talking about today. Our philosophy is that to become data-driven, industrial companies need to have a widespread use of data in their plant operations. And for that, there is some key factors. The first is to empower the people at their level. That means if we can provide them the ability to build by themselves the tools around data to answer their own needs, then you will have a good adhesion. And we have several cases in our customer where we get that. It's really, it gives, I would say, it gives them agility because they don't need to wait for a central IT team or data experts team to do this construction work and to be ready to use data. It's really they own their usage of the data, and so they are, I would say, very agile, and they can tackle things in real time. Another aspect is, I would say, in the industry, we had and I was a user of, I would say, legacy tools in the past. Really, we focus a lot on the user experience and user interface in order that it is something that people want to use every day. And really, I think to conclude, what is important is the value you give to these operational teams. If they are just consumer of tools and data, it will not be good. If they are part of this by building by themselves and I would say improving and how to say continuously adapting their tools to the evolution of their needs, there it's really we get very, very good adhesion.
Okay, so that sounds absolutely good to me, because it means you're using the creativity of the employees in the company to improve their own processes. And if I understand you correctly, your tool is in the position to really to enable employees, production managers to really combine and create data they really need to improve their processes. And then, if that is correct, I agree entirely with you. That is a high motivation to really be connected to this new digital approach. On the one hand side, being in line with the ESG commitments, and on the other hand, doing things better and increase the competitiveness of the own company.
Yeah, and there is another aspect, is the platform approach. That means everyone shares the same data. That means you don't have the silo you have today, because today maintenance people, they have their maintenance software. Production people, they have their production software. Quality people, they have their quality software. And it's really siloed. On top of the silo of the different departments, you have silo in the IT systems. And what we bring is to break all this silo, so everybody shares the same information, and it gives momentum, and particularly to team work by combining multidisciplinary approach. And sustainability is really a subject of multidisciplinary approach. You cannot it cannot be just one expert on one aspect. You need really to bring together several competencies to solve these aspects.
Yeah, so it uses really the team approach. This is embedded in the software as well, that everybody in the company can behave like one team, one, let's say, company team to achieve the objectives. That's
exactly. Just to go ahead, I'm giving you just two examples of use case. So we have one in metallurgy industry, where here we say the transformation is driven by customer pressure. They want to know, for this type of steel or this batch of steel, what is the carbon footprint? Because as it has a high carbon content, it's really important for the company who will transform this steel. So here we can see in this drawing that you have traceability information everywhere, from the raw material And here it's interesting because in steel industries, they use a lot of scraps. So really we have a concept of circularity, which is coming in. And if your scraps are coming from abroad, or if they are coming from local recycling, it has not at all the same impact into your carbon footprint. Then you have the energy consumption. So in metallurgical industry, it's mainly gas and electricity, depending on the process. But you also have some monitoring on emissions, because sometimes you will have to implement measurement on the stack to measure what you really emit in terms of not necessarily CO2, but other polluants. And really the idea here, the first target is to be able to say, okay, this product, this batch, how much greenhouse gas emission. But having said that, when you have all this in place, you are able to understand better why you consume more for one batch compared to another in the electric arc furnace. Then you can change your recipe, you can change the way you operate your furnace, you can optimize all of that. And you will reduce, by doing so, your energy consumption and your greenhouse gas footprint. So really, it's a question of drivers, and the reason why you are doing that, it's not really a big issue. I mean, here the pressure is coming from customer, but at the end, you can find different application of your data-driven plant operation approach that will generate competitiveness or improve the way you operate your plants. So really, we should consider all of that as an opportunity to improve. Another example, which is driven by really completely different aspects, is biomass energy production. So the idea is to use, I would say, wood from the forest that will not be used to build house or furnitures, so smaller wood parts. And here, in this industry, there is some regulatory constraint with a RED II regulation, where you have to prove that the biomass you are using and the CO2 footprint of this biomass, mainly the transportation, is guaranteeing you a certain level of CO2 footprint for the energy you produce, either electricity or steam or hot water. So here, the traceability of the supply chain is also key. You need also to have some follow-up on the different aspects of the biomass fired plants. But I would say the first point is compliance with this regulation and the traceability of the raw material. But at the end, you will have to look at the efficiency of your installation, typically how you operate your boiler, how you operate your turbine. And here also you have many aspects where you can optimize. You can make some arbitration between producing more electricity, producing more steam, etc., etc. So really, we can see that from a compliance pressure, you can bring improvement by becoming data-driven in this kind of operations. And I will end there. If you have any question, we can go a bit deeper. I think we are just in time.
Okay, Mathieu, really impressive overview. I think it is clear now. It is clear now how powerful, right, an ESG initiative can be if you are doing the right things and the things right. So I think back to Mario.
Yeah. Thank you.
Any questions received?
Yeah, I just get a question, but it has been answered. I noticed it was about the SAP approach that they cover 80 to 90% of carbon footprint. And the example was given also for maintenance. You can find this in the frequent asked questions, but I think it has been answered. I have another question here. What is the recommended architecture to store data?
Okay, Mario. As we mentioned with Maxime, I think this I would say what we are talking about is really a corporate issue. And if we say that, it means that you need to have a centralized approach in terms of architecture, in order that you can bring together the data from your different plant operations, to bring together also the data from your supply chain. And there is another aspect that goes for this kind of approach is if we look ahead, the idea at the end is to share information between companies, because the supply chain is not just one corporation, it's many third parties. That means sharing information will be critical in the future. So centralized approach together with, I would say, cloud approach, where exchange can be easily done through APIs and etc. is really, I would say, the tendency we will see in the coming years.
Okay.
Maxime, I don't know if you have comments on that.
No, I agree. The complexity that we stumble across sometimes is that we get lots of data from different sources, and having one repository where you can mix the different origins, which will be like sometimes shipments, sometimes energy consumption, sometimes invoicing is critical. I think this consistency of format and picking up from the same box.
Okay, there's another one, gentlemen. What is the implementation phase looks like, and what is the timing?
Okay, so I think we'll cut the answer in two, because there is really the ESG approach, and Maxime will tell about this. In terms of, I would say, solution, a platform approach, let's say that usually we cut it in 3 steps. A first step where we do a pilot implementation on a specific part of a plant. The idea is to how to say, embark people in this project and to understand what are the key success factors in order to deploy at a larger scale. So it's much more a phase where the idea is to take one example of use case of production line in order to how to say, understand the way the company is working, and then to implement on the full first sites, and then to deploy. To give you an idea, depending on industry and maturity, the first part, that means pilot plus implementation of a first site, is something around 3 to 9 months. And we have customers that are doing then worldwide deployment on tens of sites, and this is something that is usually scheduled over a 3-year approach, a 3-year schedule.
And I think probably to bring the ESG part, making a GHG assessment and understanding, really getting down to what is material for that company, because you don't want to model everything depending on the industry that you're in. It's also, I would say, 3 to 9 months, probably more 6 to 9 months, to get a decent preliminary GHG assessment, understanding what are the key parameters. And they will really vary greatly. I give you 2 examples. In the commodities, like in chemical commodities, you sometimes have very little waste. You know that you basically have most of your tower bottoms that are recirculated, and you manage to basically manage very, very little waste. So most commodities, very little waste. You don't need to worry about waste allocation, for instance. If you are in the fine chemicals and you need to clean a batch reactor every time with 4 or 5 cleaning with a solvent, because you need to reach a level of purity and cleanliness in the reactor, a discard batch of solvent will actually carry a lot of carbon footprint. And in that case, it means then that you would really think that when you move across to data gathering, you will need to gather all this data and allocate them to the right product, because at high level, otherwise you will probably be stuck. So I think, yeah, you need to have this diagnostic first to see what are the things that really matter, and it really depends business case by business case and value chains by value chains. And I think it's important to have the technical aspects covered, so people who understand how to calculate GHG, and how to gather the data and how to articulate all this. But having understanding of the value chain, internal or external, is absolutely critical, because that's where the problems are. Just as a molecule that everyone understands, paracetamol or ibuprofen, you would have 4 or 5 different ways to make them, and you would have some, the carbon footprint can be 1 to 10. So understanding which is the one that you are using is critical.
Okay, thank you, Maxime. There is the last question and one remark from my side. We have learned today that beside the ERP solutions, the optimistic way is to have to empower people for transition of energy. That's first. And the second question is, what is the ROI time, return on investment time, for such a project?
Okay, so regarding the improvement, and this is a link to the second part of the question, is if the driver of what you do is really to provide the carbon footprint either to your customer or to provide the proper reporting for compliance to the regulatory authorities or certification bodies, here there is, I would say, there is no real return on investment. You have to do it, and it's like this. But what is interesting is while you are building all the data system to provide this information, at the same time, what you have done is empowering you to improve the different aspects of your industrial performance. And here, the ROI we have from our customer, what they tell us is that it's always less than 1 year, including all the time they spent to implement the solution, etc. It's really we have return on investment which are on this order of magnitude. But I need to specify one thing, is to get results doing this approach, and Mario and Thomas, you mentioned the human aspect of the system. You need 3 things. Tools, it's what we were talking about, tools and information. But you need 2 things that need to be, I would say, involved to achieve gains. The first one is expertise on your business and your processes. I would say really technical expertise. And the second one, which you often forget, it's management, methodology, organization, animation. So really, how you motivate people, or you structure your organization in order that you use the information in order to transform this information into actions. You get ROI only if you do actions. Really, I think this is really a key message, and the human aspects of this kind of transformation is really, really important.
Okay, thank you very much. This brings us to the end of this very interesting webinar. Thank you very much for this, and we are looking forward for the next one. Thank you very much.